Hey, calculus class. Got a couple questions on the Lorentz contraction that gives us the relativistic length L. And so what I want to do is I want to write this one down. This is a cool problem, so have a little fun with this one. L equals, now that's the relativistic length. L will equal whatever that resting length is, which we're going to use the notation L naught, L subscript 0, times the square root of 1 minus the velocity that it's traveling squared divided by the speed of light squared, like so. So this is known as the Lorentz contraction. Let's just make a couple notes of this. This one's cool. Just enjoy this one. It's a lot of fun. If you're just worried about the answer to the problem, hang tight. We'll get there. But if you find this interesting, grab your calculator. We're going to do some exploration. The Lorentz contraction. I just pointed to the L. That's our the relative length. This is the length at rest. And this is the velocity. And this is the speed of light. In a vacuum. Right there. Alright, so what we're going to do, the first thing that we want to do is answer this question: what's the limit as the velocity approaches the speed of light from the left? Now I tell you what, that's the only way we're going to approach the speed of light, because the velocity won't be greater than the speed of light. It's just, that's our cosmic speed limit. So v is not going to be bigger than c. So that's why it approaches it from the left. Just like if we're approaching infinity, we can only approach it from the left. But c is not infinity, it's actually a number. And just a FYI, c, the speed of light, is 299,792,458 meters per second. I'll just put some commas in there. That's a little note. Hey, that's how fast light is. That's about, just for those of you that want to know miles per hour, well, I'm not going to give you miles per hour. I'll give you miles per second, because that's a big number by itself. It's about 186,000 miles per second. I'll just put that in parentheses. There's our metric system, though. Meters per second. Well, all right. As v is getting closer to c, notice how this becomes a c. v is approaching c. And if it were able to equal c, you'd have c squared divided by c squared, which would be 1. 1 minus 1 is 0. The square root of 0 is 0. 0 times the length at rest would tell us if that craft were to go the speed of light, it would shrink to the length of 0. And that's our answer for the limit. When we want to say, now there's more fun than just this answer, so hang tight. The limit of this length as v approaches c from the left is equal to 0. There's your answer. It shrinks to 0. But let's have a little more fun than just that. I'm going to grab my calculator, and incidentally, this, what you see on the screen, is left over from the help session on Friday. There was a question number 15. The question number 15 was asked, and I love that question because we were able to look at the graph and the table, the numerical values. So to answer that question, there was actually the numerical, graphical, and analytical approach all in that question number 15. So just a reminder, number 15 we did cover, and I recorded it in the Blackboard, so it's in the Blackboard recording. So if you struggled with number 15, hey, the whole recording, it's only like 10 minutes long. You can find that in the Blackboard Collaborate Ultra tab. Click on the little hamburger in the upper left, it's the menu tab, 3 horizontal bars, and select recording. You can pick out Friday's class. Now the class you did not have to attend. It was just if anybody had questions, they could get in there and ask those questions. But you know what? Back to this Lorentz contraction. This is the one that's just too fun to not enjoy. So here's what we're going to do today. Grab your calculator. We don't care about anything on the home screen here. In fact, what we're going to do is we're going to build a program. I want you to push program on your calculator right now. And you are going to create a new program. You are a computer programmer today. Whatever day that you're watching this, you are a computer programmer. So we're going to select Create New. And what should we call this program? That's what I was thinking too. I was thinking this. And I want you to know something about programs. When you write a program in your calculator, you're limited to 8 characters. You're limited to 8 characters. So let's write that out. Okay, so back to my Lorentz. Now the alpha lock is on, so we just have to find the letters. They're written in green on your keyboard. Since it's flashing an A, the alpha lock is on. So we're just going to write out Lorentz. There we go. Oh, I don't want 2 Z's on there. There we go. And you hit enter. Now what you have then is your first line of code. Now what I like to do when I create a program in my calculator, the very first command that I like to say is clear the home screen. So then when I'm working on it, it just clears everything out so I don't have to worry about doing that. Push the program button. You're going to push that button a lot now. And what we're searching for is something that says clear home. So notice you can arrow right and left and look through. Here's a clear home on number 8. You can push 8 or you can arrow down to it, whatever you want to do. Let's make that our first command and then hit enter. Now we need to see that colon here, so we're going to declare another line of code. And you know, a good line of code right now would be for the user to input L and V. So we're going to push that program button again, and we're looking for the word prompt. Prompt. So see if you can find prompt. There it is. And what we'll do is we'll prompt for the variables that we're interested in. L. Now notice the alpha lock is not flashing, so I have to hit green button. L. And then I'll push the comma, which is right above the 7, and V. Alpha V. There we go. So it's going to prompt for L and V, which is the length at rest and then the velocity that it's traveling. Now the calculator is going to need to know that the speed of light is 299,792,458 meters per second. So we just need to write that big number in there. It's almost 300 million meters per second. And we're going to store that. See, there's a little store button here. Store it to, which letter should we use? That's what I was thinking too. C. Good call. Alright, so now your calculator knows what L, V, and C are. So all we have to do is write the formula in that is given, that is given to us right, let me get my cursor over here, right here. We're going to write this formula in. That won't be too bad. So we'll say L square root 1 minus V squared divided by C squared. Like so. Seal that up with a parenthesis. Now I think it needs to be stored to something, so we're going to store this. This is the length, the relativistic length. Let's store that to R. R seems appropriate. There we go. So now on our formula, what's happening is this, the relativistic length, this is R, because we used L for this length, and then this one is R. We're using R to store it in our program. You don't want 2 L's, that would be weird, right? Alright, so now it knows what it is. All we have to do now is display R. So let's hit enter. program, and we're looking for something that says display. Here it is, number 3, display R, alpha R. You've written your first program. Should we try it out? Push second quit to leave your program edit. Now you'll notice there's some leftover stuff on the screen. When we push program and call up Lorentz and hit enter, it's going to clear everything out. Yeah, it did, because that was our first command. It's going to quickly prompt the user to enter in the length. You know what I'm going to use? I'm going to use 100 meters for an example to see if this thing's working. So the length of the craft is 100 meters. And how fast is it traveling? Well, let's say it's traveling 100 million meters per second. Looks like it's 94.2727 meters long. Let's try another one. The length is 100, and this is just a test to make sure it's working. You can see if your program is working. Now let's go 200 million. 1, 2, 3, 1, 2, 3. That might have been better in scientific notation, but I'm going to be dramatic here. So at 200 million meters per second, that length of the craft has shrunk to 74, just a touch under 74.5 feet. So you can see it shrinking. Call it up again. I'm just hitting the enter to call it up again, otherwise you can push program and then call it up. Let's use that same 100 meter length craft. Now we're doing 295 million, so 1, 2, 3, 1, 2, 3, got 6 of those zeros, 295 million meters per second. Now we know it's shrinking, it's getting smaller and smaller. Now we're down to 17.8 meters. Same 100 meter craft. Now we're going 299 million. I think I'm going to incorporate a little scientific notation now. There we go. We're getting pretty close to the speed of light, right? That 100 meter craft has shrunk to 7 meters. All right. Well, you can keep playing with your program, but I think we got it, right? Had a little fun. Lorentz contraction formula. If you want, if you enjoyed this, that is, if you're still watching this, then you might have enjoyed it. If you've hung up long ago, you're not listening to me anymore. But the Lorentz contraction formula, there's calculators and stuff online if you want to search for that. It's pretty fun, but now we've made our own, so we've got that done.